got to this computer. Thanks. Okay, so what is RAG? So the large language models, which are trained on large corpus of data, they basically lack, couple of things. For example, the first is domain specific information. So as I said, these LLMs are trained on large corpus of data, and it is scraped from internet and it is cleaned. And this data is actually from all the domains. So some data from the healthcare domain, some from the manufacturing, some from from different domains. So these LLMs can actually answer the high level questions on all of these domains, but they lack on a specific domain. So they are not trained on just one specific domain. For example, if I want to use it for legal purpose, then they actually don't know all the IPCs of the Indian penal code, right? And if I'm doing some research on cancer, then this model may not have sufficient information to answer those very pinpointed specific questions of a domain. Okay, so what I mean to say is these large language models are trained on a very general data, general purpose data, which is spread all across the domains. So if we need to have something which can have data from a specific domain, then we should use the RAG. Okay. So also these large language models lack the real-time information. So that means, these models have some cutoff date. For example, if there is a model which has been trained on the data till 2023. Okay, so whatever data was there till 2023 on the current affairs and all those things, it was trained. But now, if you ask any question on any incident which happened after that cutoff date, then this LLM will struggle to answer, because it cannot answer on anything on which it is not trained. So that is the second problem. The third problem is it does not have access to your personal information. So if you have any emails in your mailbox or on your company's Outlook, then it does not have any idea what email you have, right? Whatever information which is there in your Outlook, it is not trained on that information, right? So that is the third problem. Or maybe it may be your company's database, your company's policies, procedures, whatever, which is your company's proprietary data. So on that data, these LLMs are not trained, so they cannot give you any answer regarding those policies. Okay, so these are the 3-4 points on which these large language models basically lack. And in order to overcome this problem, what we are going to do is we should be using RAG, which is Retrieval Augmented Generation. Okay. For example, it has two main parts. One is the retrieval and the second is the generation. For example, if you ask ChatGPT, how do I reset my device? So it will have no clue what device you are talking about, isn't it? Okay. So what we can do is, in order to get such questions answered which are specific to your data, to your procedures or your SOPs or your guidelines, what you can do is you can take your information and you can put it in a specific database which is called as the vector database. Okay, so this database will have the information of all of your products, all of your catalogs, right? For example, this question may be from any mobile manufacturing company. Okay, so if the user is asking, how do I reset my device? Then we should augment that particular question with some context or some details or some data which is specific to the device the user is talking about. So what we will do, we will take all those catalogs of that manufacturing company of the phones, and we will vectorize that data and we will put that in a vector database. And when the user asks this question, what will happen is the information on that device will be retrieved from that vector database, and your question will be augmented with that context, and it will be sent to the large language model. Making sense? So earlier, the large language model is having no clue about this device, but since we have created one vector database with all those information from your catalogs, so now the most relevant information will be retrieved from this database and it will be sent along with your question. So you have something called as the prompt. So you will be writing some prompt saying that you are a customer service assistant, answer the user's questions given the following context. And this context is coming from your vector database. Now, large language model can actually answer your question based on the context which is retrieved from vector database. I hope this is clear now. Why this RAG is important. Okay. Any questions so far?
No, Surendra, it's
All
good.
right. So we have two things, two main parts. One is how do we load this data into this vector database? So that is the most important thing. The first part is how to load this data. Second most important part is how to retrieve the relevant data. So once the user asks any question, how to retrieve the most relevant data. And the third is the generation of the final answer or the synthesis of the final answer. So these are the three main components. So retrieval, it searches external source that may be like document database or web or relevant information. Generation is it then uses that retrieved information to enhance the large language model's response, grounding it in real world up to date data. Okay, so this RAG is not, I mean, essentially it can be anything, like it can be any external data source, it can be any weather API, right? So if you are calling an API which has some weather information, that is also a kind of RAG, because your large language model is not having any information on the current weather conditions, right? So what we can do is we can call some weather API. So that will also be called as a RAG, because at the runtime, we are going to some external source, we are finding the relevant information and the context. And along with the question, we are sending that context to the large language model for the final answer. Okay. So that was on RAG. Now, what is RAG over unstructured data? So the data is primarily divided into three parts. First is your structured data, which is there in the database. Second is your unstructured database, which is like Word, HTML, and text files. And third is semi-structured data. So you can see in this diagram, we have like Word files, we have HTML files, we have text files. So what are these? All these are unstructured data. They are not structured, they are there in the PDF files, whatever data, right? So this data is called unstructured because it has no structure as it, right? But if you have any data in the CSV files, it will have columns, it will have different columns, or maybe in the Excel file, it will have columns, and then those columns are populated with some values. So this kind of data, or if we are talking about some SQL server or some Oracle database, that information or the data which is there in the database is highly structured data, right? So and we may have some emails in our Gmail box, we may have some data in the Notions, we may have some data in the Confluence, right? So data is basically segregated into these three components. This is unstructured data, this is semi-structured data, this is structured data. But when we talk about RAG, although it can work on top of no all these kind of data, but usually when we talk about RAG, that means we are talking about unstructured data. Okay. So, this RAG concept is more handy and more fruitful for unstructured data. So, as I said, our first step is to load the data into the system. Okay. So, what we need to do is we need to extract the information out of these structured and unstructured data. Then, once we fetch that data or the content out of these files, we need to create some vector embeddings. Okay, so that we can store them in some vector database for similarity search. Okay, so what will happen is, let's say we have 10 pages in our Word document. Okay, so the first step is to load the data. We will load that particular file. We will fetch the content of all those 10 pages. And out of those 10 pages, we will create some vector embeddings. What are embeddings? It's covered in the next page. Okay, so once vector embedding is nothing but it's a vector representation of your data, of your content. Once we have created these embeddings for our data, what we have to do is we have to store those embeddings in a special database which is called as the vector database. Okay, so I will cover what embeddings are in the next slide. So this is to give you one high level picture how to load the data. We have the data, we fetch the content, we create embeddings, and we store them in the vector database. Clear? Third is then what is embeddings? Embeddings are actually, let's say, this is a three-dimensional space, right? We have x-axis, we have y-axis, and we have z-axis. Now, what will happen is if I want to create a vector, then what I need to do is these dimensions. Let's say I talk about this point. So this point has some x coordinate, it has some y coordinate, and it has some z coordinate also. So once it has all those three values, it's nothing but it's a vector from 0, 0, 0 till this point. Okay. Similarly, what we want to do is when we create embeddings, we create such vectors not in 2 or 3 dimension, but in a very high dimensional space. Higher dimensional means there will be dimensions something around 500, 1000, 1500, or 3000. Okay, right now you can see just 3 dimensions, right? All these points have some x coordinate, some y coordinate, and some z coordinate. And based on those values, we can create one vector. Similarly, what we have to do is whatever unstructured data we have, whatever chunks we have to represent that particular piece of text in the form of a vector. And that vector is not in 2 or 3 dimension, but think it of a multi-dimensional vector space which has like 1500 dimensions. Are you getting? So this is the purpose of embedding. We need to create the vectors for those chunks, those piece of data. And what is the purpose? Why we are doing so? By creating the embeddings, what will happen is all the data which is very similar in meaning to each other, in semantic meaning. When we say semantic means for example, we have a sentence like the cat is sleeping. Let's say this particular circle, let me take a pointer. Not so-
Surendra,
Mhm.
1500 dimensions means to represent one word or one chunk. So we are saying that it will be having 1500 data points to represent.
Exactly. For example, this particular point is having some value, right? Let's say this is 4, comma 0.5, and then some y-axis also, right? So by putting those three coordinates, let's say 3, comma 4, comma 5, we are defining that particular point. This point is described by 3 points or 3 axes, isn't it? Some 4, comma this one, and on this plane also, right? Similarly, when we create embedding for a sentence, for example, this sentence, the cat is sleeping. So in that multi-dimensional space, we will be creating one vector, or we will create one point. Okay, so this if you join it by 0, 0, 0, this is one vector. Okay, so in those 1500 dimensions, we will be able to create one vector, and that vector is on the basis of the different characteristics of that particular piece of words. Okay, so if we talk about cats, all the cats will be located, all the cats and dogs and such animals, those vectors will be very close to each other because they are very similar in the meaning with each other. All the so these are the domestic animals, maybe these are the wild animals, but you will see all the living things, right? All the living things will be more close to each other than some non-living things. They will have some different vectors or some different values because they have some different attributes, isn't it? So these vectors are defined on the basis of attributes, which are nothing but the dimensions. So there are 1500 different attributes on which a particular piece of text is categorized, and then its location on the space is decided. Is
Surendra,
it?
here
Hmm.
What is that point represents here?
Yeah. So let's say we talk about this point. Okay. So this point basically is a embedding vector, but this is on just 3 dimensions. So this point will define this vector. Okay. So we have reached, so I mean, actually, we are not going to define, we have some embedding models. So when we feed our data to those embeddings models, it will create these vectors for those piece of text. So this will basically tell you the vector of this word is this. That means, I mean, how to explain you? All the similar words are located in the same space. That's what. See, this space is actually help you to position the different words close to each other. Okay, so once these vectors are created, you will see all the words or all the sentences which have similar meaning will be located very close to each other. They have some semantic similarity. Getting?
Just like our SQL database, when we design the tables, when we
Mhm.
actually keep the, similar kind of information in a particular table in SQL. So
Right.
that kind of
So
scenarios.
I mean you can say that, but in this case,
Hmm.
so that SQL is having only key values in the
Yes,
sense the
yes.
literal words.
Hmm.
But let's say your SQL is having a word like sleep. Okay,
Hmm.
so that sleep or that record can only be retrieved if you are making a query like select asterisk from this table where the word is equal
Hmm.
to sleep. Okay, but you cannot search the sleep word with the nap. If you replace the sleep with the nap, then your results will be zero.
Yes.
But in this case, our intention is to search those chunks or those sentences with the help of their meaning instead of the
Hmm.
keyword search. Okay, so that's the whole purpose. So when we have our PDF, when we feed our PDF to these embedding models, it will break it into small pieces of sentences. Let's say two sentence is a one chunk. So that chunk will then be placed somewhere in this vector space like this. Okay,
It was, Surendra,
hmm,
it will remain always be a 3D, or it can be 2D, or it can be, more
ha.
than 3D
So,
also.
so that depends on the embedding model which we
Mm.
use. So for this illustration purpose, I'm using just, I mean these 2 or 3 dimension. But in
Mhm.
real, these embedding models are 1500 dimensional.
Oh
That
my God.
cannot be shown on this particular
Mhm.
piece of,
Mhm.
paper, right?
The more D it gets B, then the more close or more, accurate
Exactly,
answer we would get.
exactly.
Mm.
So we have vector embedding models of 3000 dimensions also.
Mm.
So when you feed data with the help of those embedding models, then it will position or locate your sentences by judging the meaning of that with 300 dimensions.
Mhm.
Okay, whether it's a living, it's a non-living, it can fly, it can float, it can sleep, it right. Those are
Mhm.
the attributes, but we never know what are those 3000 attributes. So that algorithm does it on its own.
Mhm. We have no control of setting these vectorization within
Exactly,
the model.
exactly,
It it it,
exactly.
it, it happens automatically.
Automatically.
Okay,
Mm.
so we don't define as such that it's going to be the n-dimensional like that.
Yes,
So
yes, yes. So
okay,
once
okay.
we choose a model, then that is pre-decided. If I'm
Mm.
using OpenAI embedding model that has 1500 dimension, once I give its name, then it will automatically take those 1500 dimension. Okay. If I am taking large one,
Mm.
then it will have 3000 dimensions already set. Then it will segregate your data or align your data in the vector space on those 3000 attributes.
So the high dimension would take the high computational things, huh?
Exactly. So that's the trade-off. That will be
Mm.
more accurate, but at the same time, your computation cost will increase because it has to align your data into 3000 dimension data. That may also, take more space also.
Mhm.
Computation as well as the space.
Suppose our 1 MB of PDF might be taking like a 10 MB of space in
No, no,
vectorization, maybe.
not
Is that
really.
so?
No,
Okay.
not really. So once you create a vector, na, let's say you have create a vector of a chunk. So what will happen is if you see that vector, it will be like 1.2 something 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 on one dimension. It has other dimension, it has a value of 1.0. On other, it may have some 3 or something like that. So there will be numbers, and so this will be basically an array. Okay, so the first chunk is like this one. Second chunk will have some other value. So it will be a list of values. And the number of columns are actually are the number of dimensions we have. If you have 1500 dimensions, then it will have 1500 unique values, just like X, Y, Z coordinate. It will have some coordinates for those 1500 attributes. Okay. Then the second chunk will have some different values. The third chunk will have some different values. And all these values, so all these values are actually stored in your vector database. Okay. The things will get more clear once I will explain the slides to come. Okay.
And the process for vectorizing is different for words. I mean the text and the images, or
Yes, yes,
so it is
it does.
different,
So
but all of them would get be vectorized, huh?
yeah, yeah. So
Okay.
if you want, you can have a separate vector database for images and separate vector database for your text. Okay. If you want to have a common, then common will also work. But first, what it will do is from that image, it will create some text. Okay. The text which will explain that image.
Describing that image.
If you have a plane in the sky, so it will first create the caption that a plane is there in the sky. And for that text, it will create the text embedding, and in the same vector space you can put it. And once you do some search, it will pull that particular embedding, and then you have to link that embedding with the image so that that image can be pulled as a response also. So
Yeah.
that we will cover in our next lecture, which is RAG over complex data.
The same goes to videos also, huh?
Yes, yes.
Okay, we'll check it later. Thank you.
Okay, so embeddings are generated by using a machine learning model, typically a transformer based model like BERT. Okay, you can also create your own embedding models. It's nothing but a neural network. You have to choose your input layers, output layers, and with some data you have to train it. Okay, transform models like BERT, OpenAI, embedding, etc. These models take a piece of text such as sentence, paragraph, or document and convert it into high dimensional numerical vector. Okay, this model is trained such that pieces of text with similar meaning. So this is the goal actually. Similar meaning are mapped to similar regions in the vector space. So all these words may have, all these vectors have similar meaning. These two have similar meaning. These two have similar meaning, like that. Okay, so we are basically creating some groups or clusters where the similar looking meanings, similar looking sentences are close to each other. Okay, so in our example, the cat is sleeping and a cat is taking a nap. They have almost vectors which are very close to each other. And how do we calculate the closeness? With the help of cosine similarity. Okay, when you calculate the cos theta, although it will be done automatically by your APIs, but for just for your information, because this is something which is asked in the interviews, how you can calculate similarities between vectors, what are the different ways. So you can calculate by cos theta, cosine similarity. Okay, so that is used most of the
I didn't
time.
get this point. I mean, how we
Yeah.
can check the similarity?
So we need to calculate the cos theta. We have two vectors, as I said. So this is first vector and this is second vector. If I need to see how similar these two vectors are, then how I will calculate? I will calculate the cos theta. Theta is the
Angle between them.
angle between these two vectors. The if they are very similar, then they may have theta tends to 0. Right?
Okay.
That
Almost
angle will
zero.
be almost 0, and your cos 0 will be equal to 1. That is, they are very similar.
Got it. So these vectors are nothing but the angles, huh? So we can check angle
Vectors.
between two vectors to check
Hmm.
the similarity,
Hmm.
and that is cos theta. Why it is cos theta only, not sin theta?
Because we are calculating the similarity, right?
Okay.
Similarity, one means they are most similar. If you go away, if you calculate the similarity between two vectors which are perpendicular to each other, that means theta is equal to 90 and cos 90 is 0. That means they are not similar.
Okay.
You can also take sine theta, but you have to then reverse the, you have to calculate the inverse of it.
It's easier to use cos rather than
Yeah.
other. That's the reason.
Exactly.
I mean, this question might be also asked, like, why cos
Definitely.
theta only?
Exactly.
The logic behind it. It's like 90. 90 means no similarity.
Right. Cos 90 means they are in very different directions. They have different meaning altogether. Okay. And cos.
I think 180 should be the most poles
Exactly.
apart kind of.
Cos 180 is -1.
-1. Okay. Poles apart. Like, ekdam
Yeah.
reverse.
But everything is being taken care by our APIs when we do similarity search and okay.
And one more, adding to what Surendra said, 0 and 1 is the most commonly used, right, in system. So that is also one of the reasons. If you use other like sine, tan, or anything, then there is a large variation, and even the identification in the system, zeros and ones will be difficult.
Exactly.
And suppose we are fitting the same data, then it will be having the same points. So there will be no embedding created, new embedding created. Kind of like in PDF, we are trying to embed and having same sentence multiple times, maybe. So in that case,
those will be overlapping. Yeah.
Overlapping. That will be not considered as a new point.
No, that will be considered as a new point, but those will be duplicates basically, right? So if they are separate chunks, then there will be separate vectors. Those vectors will be overlapping each other. Okay, their values will be similar, but they will be different vectors. But there are ways, once you retrieve the most relevant vectors, then there are ways actually you can reduce the duplicates. Okay. But when you do a search, it will come once the search is over. Let's say you have made a setting that I need 5 most relevant chunks or similar chunks. Then it will give you those 5 chunks. Then you can remove the duplicates out of those. So there are different algorithms and ways by which you can remove these.
So we can control the filter and filters the results, whatever results we have.
Exactly. So you can, I mean, this is called as the ranking. So once you retrieve your most similar chunks, then you can define how you want to rank them. You want to rank them that you want the results which the chunks which are more distinct to each other. They are different. They should not have anything common in that. So there are a lot of ways actually how you can do all those things. Okay. So let's talk about the RAG pipeline over the document. So this is end-to-end document. Okay. Okay. So what you have is, this is the RAG pipeline. This is actually not complete. Let me bring the complete diagram. Just a second. Just a second, guys. Let me bring the. Can you guys see my screen? No, right?
We are seeing you over the screen.
Now you can.
Yes.
Okay, so this is the complete diagram. So that was having just this part. So this is the rack pipeline over unstructured data end to end. So this we have already talked. So this is the most important part, how to load your data, how to create the chunks, how to, okay, let me go through one more time. So this is rack pipeline over unstructured data. Unstructured means the data which is in your HTML file, Word file, PDF files and all those. So what we need to do is, first of all, we need to load this data. Okay, and we need to extract the text. Okay, that Word file may have some formatting and some other things. Our aim is to extract only the text part of it. Okay, so we'll be extracting those text. Okay, so let's say if we have 3 pages in our PDF, so when we extract the text, we will have 3 pages. Okay, 3 page of text is there. And in order to do that, we will be taking help of document loaders. And since we are using LangChain framework, there are a lot of document loaders which are provided by LangChain, which we can use. For example, in order to load the PDF, we can use PDF loaders, HTML loaders, docx loaders, right? For different type of input documents, we have different loaders defined in LangChain. So we can make use of them to import these documents and then to extract the text out of it. Okay, so once we have the text, our next step is to create the chunks out of those. Let's say this PDF is 300-page long. Okay, so this will be 300-page long, and we should not be passing those 300 directly into our vector space. Okay, the problem, one problem will be that, once you fetch the 300 pages, your context window will be consuming more number of tokens. So what we usually do is, those extracted texts are further chunked into smaller parts. Okay, and then and that is again done with the help of LangChain text splitters. Okay, one page will be chunked into, let's say, 2 or 3 pages. So that is configuration which we need to do. And then once those chunks are created, as we discussed, we will be creating some embeddings with the help of some embedding model. That can be from Hugging Face, that can be from OpenAI, whatever is your choice. Use that embedding models, and based on that models, your vectors will be created like that: 2, 4, 6, 8, something. If it's a 1500 dimension, that each chunk will have some 1500 values separated by comma. Okay, so these are coordinates basically in that high dimension space. So once you are done with embeddings, you have to put those embeddings into the vector database. So what these are is the special databases which can store such kind of data. For example, we have Chroma database, we have Pinecone database, we have FAISS, FAISS, Facebook AI search similarity search database. We have Quadrant. So these are a couple of database which are very much popular choice for the vector databases. So this part is all about loading your data. This is your ingestion pipeline. Okay, how to load your data into the vector database. This is proprietary data which we are having in our company, our own data. Okay, which our LLM is not trained, right? So LLM has no information or no knowledge about this data. So what we want to do is, we want to augment our LLMs with this data. So the next step is our user query. Once the user asks a query, what will happen? First, it will again be converted into a embedding. Which embedding? By using the same embedding models which we use to create embeddings for our data, right? Our unstructured data. I have to use the same embedding models. I cannot use different, right? Because different embedding models have different attributes. 1500, some may have 3000, some may have 1000. So once I create this embedding for my question, let's say my question is, what is neural network? So it will create embedding of that single sentence into 1500 dimension vector. Now this vector will be searched in this vector database, and it will see this vector is close to which all embeddings in my vector database. If I'm asking what is neural network, then it will see, is this similar to my vector embedding of my first chunk? No. Is it similar to this one? What is my cos theta? Is it close to 0? Yes. Then I will pick the top 3 embeddings which are most closer to my question. Is it clear or not? This is how the similarity search happens basically. It has very complex algorithm in the backend, but at a high level, this is how I will be able to retrieve 3 most similar chunks from my vector database. Yeah, please.
Just asking like what all tools we would be using till vector database. The two you have mentioned like embedding model we need to select, and the vector database, whatever the database
Yes.
should be having. So just 2 tools or any
Yeah,
other
I
tool?
mean, we will be using LangChain tool, LangChain document loaders, LangChain text splitters, and LangChain to we will be using embedding model, but again, the framework will be LangChain itself and the vector. So the choice is like the embedding model and your vector database. Okay.
Okay, so the loader also, kind
Loader
of.
also. Yeah, I mean, we will do it. One practical we will do. What is the time? We will do it today itself. Okay.
Okay.
And Surendra, I think we have two things like distance metrics, like Euclidean distance, and the one with which we were
Manhattan
discussing,
distance.
Manhattan, and this one cosine similarity.
Mm-hmm.
So I think based on the use cases, I think both are used. Some of the times we use Euclidean distances also, right?
No,
And
I
some
mean
other
for this RAG pipeline, most of the time we use cosine similarity. Okay, we can also do hybrid search. I mean, there are a lot of variations. Okay, but we can also do hybrid search where the keyword search will also happen, and then once the keyword search has happened, on top of that we are doing the similarity search. And some people do it in the reverse way. First they will retrieve this by semantic search, and on top of it they will also do some keyword based search, normal search, and then whatever I mean, that depends on the use case. Okay, but from the point of view of which distance metrics we use cosine similarity most of the time, 99% of the time,
Okay.
because we are dealing with the vectors, right?
Yeah.
Okay, so yeah, so that is the point. So once we have the 3 topmost, so this we can define, we can have 5, we can have 10. Okay, whatever number of chunks we want, the most similar, we can configure it, how many chunks we want from the vector database. So once we have those chunks, what will happen is our query along with those chunks will be sent to our large language model. Now this large language model is having some knowledge on my question, right? Now the context has been, now this large language model is augmented with some knowledge from the external database. Now it can answer your question. Okay, so the final answer will be delivered by large language model. Since it has access to the information, it will generate some natural language answer and it will give it to the user.
So out of the selected chunks, it would select only one, the topmost one.
No, all these 3 chunks will be sent to the this large language model. So there are, I mean, as I said, there are various variations. What you can do is you can use another large language model to summarize all these 3 chunks into 2 or 3 sentences.
The conclusion kind of.
Conclusion, and then that summarization can be sent to the this main large language model. Okay, if these chunks are very big, then what I am doing is, let's say I'm using the OpenAI large language model, so that will increase the number of tokens. Okay, let's say I'm using a model which has the maximum limit of 8,000 tokens. So if I bring a lot of large chunks, what will happen is I'm consuming that window also, and that is adding to my cost as well. So in order to reduce that, I can use some open source large language model here, to which I will send these chunks and I will say summarize these chunks into 3 lines or 4 lines. Once it summarizes all the chunks, then that 50, 100 token we can send to the large language model to reduce my cost. So those are optimization techniques. So this is also something, if someone asks you how you can reduce the cost, there are, I mean, this is one of the way.
So we are sending it to LLM just to have a readable format of response. Is that so, or what exactly?
Yeah.
Output is str output, something like that.
Yeah. So these chunks are nothing but they are text from your PDF. file, right? So they are random paragraphs from the PDF. Those may be coming, first chunk may be coming from the page second chunk may be coming from the 10th page, and the other is coming from the 50th page. So they have some different context, right? So it will just use the knowledge which is there, and then it will create its own answer. Right? So they are randomly picked from different pages, right? So they may not make much sense. So since we are giving these chunks to the LLM, now LLM can synthesize answer. Also, we are giving it a prompt, right? So in the prompt, we will write instructions. This is the context below. Now what you have to do, you have to reply the user's query, and you have to keep in mind, you can put some conditions.
Okay. So it's not interacting over the net information. It just this LLM, it's just catching the chunks and making in readable format.
Yes.
Or user friendly format.
Yes.
Okay.
On my system, on my laptop, I have built one chatbot. Everything is happening on my system itself. Even large language model is on my laptop, and I'm doing all these steps on my laptop itself. Even I can turn off my internet and I can keep on working.
Perfect.
So, Surendra, you are saying we can use more than one large language model, or with large language to small language model. So in that case, we require some agent, or we can use the parallel.
No, you can do parallel, whenever you are writing your code, you can just call on one more function, which will basically use another LLM to summarize all this text, and output you can send to your this LLM.
Okay,
you can also use agents as well, right? That is, but you have to be very careful when you are using agents and when you are RAG. That we will cover later.
Okay, agents will be the upcoming topics now. We did not cover it.
Next to next lecture, yeah.
Okay, good.
So, Surendra, in this case, LLM won't use anything externally, right? It is just using the data what we have received from PDF. So it is, can we use something else than LLM? It is just to make the things readable and all. So why we need LLM for this case?
So who will generate the final answer?
The answer we have already, what we have retrieved. The only thing is we have to present it to the user in a more presentable format.
I understood your questions, but what are the alternatives actually? That's what I'm asking.
That I'm not sure.
There are no, right? This is the beauty of LLM, right? It can understand the human language. It can understand, it can summarize, it can do sentiment analysis. It can do a lot of things. That intelligence we want to use to synthesize our final answer. If you want, you can ask your LLM to add its own knowledge also. That's up to you. But that may or may not be correct. So mostly we don't, we instruct in the system prompt that you don't add anything of your own. Just keep your answer very concise based on the context provided below. That below is all these chunks. Okay? So that it does not hallucinate. The problem with the LLM applications are they hallucinate. They will confidently answer to your questions without knowing whether that is right or wrong. So in order to reduce that hallucination, we are using this RAG. Now we are giving the specific information that your answer should be based on this only. Don't create your own answers or don't add anything to it. Let's say the customer care executive is using this application, and if some user has raised some question that how to restart this particular phone, right? So whatever information which is there in the catalog, that it should use. If it uses its own intelligence, it may give some restart instructions from some other model on which it is trained. That means it will hallucinate. That we don't want.
Yeah, so I think the prompt which we are giving is very important.
Very important. Yeah, there are jobs for prompt engineer.
Yeah, if we don't give the prompt, so still LLM will hallucinate and it will still give some incorrect answer.
So that we will see next. So next, what we are going to do is hands-on.
Surendra, one question. Here, what about the confidentiality of the data? Because something maybe this information we are giving to the LLM, right? So then how about what about the confidentiality of the data?
Yeah, so I'm saying, right, this LLM can be on my laptop today, and I can use it without internet connection. So that's confidential, right? It's not
Okay.
leaving my laptop also. So the confidence actually depends how you are deploying your LLM. So if you are using the Grok APIs, or if you are directly inferencing your OpenAI, that means your data is going over the internet. That is, you are compromising on your confidentiality. Okay, so that depends where your LLM is deployed. If you are deploying your LLM in your Azure account or your AWS account, then it is secured. On top of that, if you don't want to share your personal information, what you can do is you can do some masking, before loading, or you can use some guardrails. So there is something called the guardrail. So that guardrail will help you. The input guardrail will see whatever chunk and data you are passing to the LLM that should not have any personal information, any PII data. If it is there, it will block those informations. Similarly, when it is giving answer to the user, we can have some output guardrails which will check on some. So there are filters, there are a lot of options, hate speech or sexual content and all those things. You can turn on or turn off them, right? So those filters will actually help you to filter your content which is being given to the user. So in both directions, you have guardrails. We can use guardrails.
Okay.
And even before putting our data into the system, we can mask the such information if there are any, right? We can mask the information on the PDF itself so that it does not go into the system. So there are various mechanisms by which you can do. You can deploy this LLM in your own premises, right? Or if you want that kind of confidentiality. So that depends.
So, Surendra, this was the question I got in one of the interview where he asked how you maintain the security of this LLM. What I mean, the model Gen AI project that you have worked on. So, like what we discussed, it is also one of the most frequently asked question: how to
Yes,
maintain
yes.
security.
Yeah. So just explain you, right? So you can tell all these things, if
Yeah.
you want. Whenever you deploy any model on your Azure account or your AWS account, you also have some contract with your Microsoft. In that contract, you should read, maybe you can, if you want some extra security, you can ask Microsoft to provide that. So that depends on the agreement on that Azure account, which you have got created also. Right? And then your LLM is your large language model on a shared server, or it's on a dedicated server, virtual machine, and you have your firewalls, you have your VPN setup and all these things. So yeah, so that depends on your architecture also.
Yeah.
Okay. So, and then guardrail answer, which I said that you can also tell them, and then also masking the information right at the source. This is also you can tell. And then now we will do some hands-on. We will do what? We will implement RAG system that works on unstructured data. As we studied, we will take one input file as a PDF file, PDF as an input file, and then we will implement this LangChain. Okay, what we will do, we will load the PDF using LangChain's PDF loader, split the document into chunks for efficient retrieval, create embeddings and store them in the vector database, and then we will query the vector database to generate a response. Okay. So let me share my screen. This is one.
सुरेंद्र जस्ट एक कंफ्यूजन है ये जो मॉडल्स होते हैं ना these models are the the consisting of the information or they are the they are worth to have iterations over the information or over the prompt over the chunks. So अभी तक तो मुझे लग रहा है कि मॉडल्स जो हैं ये these are the information based things, हाँ, and we can use them to get the answers of our prompts. So कुछ कंफ्यूजन है यहाँ पर, मतलब क्या
नहीं,
हर्डल है
देखो
ये?
कंफ्यूजन नहीं होना चाहिए। देखो क्या है कि दीज मॉडल्स आर एक्चुअली नथिंग बट दे आर द ट्रांसफॉर्मर बेस्ड, दे आर बेस्ड ऑन ट्रांसफॉर्मर आर्किटेक्चर एंड दे आर बेसिकली डीप न्यूरल नेटवर्क्स, है ना। दीज आर एक्चुअली मॉडल्स। For example, we have machine learning models, right? So they are machine learning models only, which are trained with the vast amount of data, so that they
They
get
have information already.
they have information, you can say. They have
Mhm.
knowledge, right? जैसे अपन एक छोटा
Mhm.
बच्चा होता है, we
Yes.
start talking to him with a lot of Hindi or
Mhm.
English. Gradually, he learns all those things. Now, if
Mhm.
you ask him a question based on his
Mhm.
previous knowledge or previous
Mhm.
learning, he can reply, right?
You can reply.
So similarly, we train a model in such a way that it knows basically what is the grammar of English, how to use
Mhm.
it, how to respond. It
Mhm.
create that intelligence
Mhm.
based on the weights, right? वो ट्रेनिंग में ऐसा ही होता है. We put lot of data, we calculate the error,
Mhm.
and then we again try to change the weights of that model. We keep on changing the weights until our error is minimized. Once the error is minimized, that means now our model is able to understand
Right.
whatever
Mhm.
input we are giving. ठीक है?
बट यहाँ पर तो हम लोग इंफॉर्मेशन वी आर गिविंग इट थ्रू रैग है ना, थ्रू
हाँ.
अनस्ट्रक्चर्ड डेटा. So we are not using models inbuilt information, because inbuilt
No,
information is
the
different. So,
inbuilt information is fine, but more than information, the important thing is now it is able to understand the language, English language. If
oh.
we are saying, if we are giving it a question, what is a neural network, and we are giving the possible answers. Now, जैसे एक बच्चे को हिंदी आती है, अब उसे मैं कहता हूँ कि ये इन्फॉर्मेशन है और ये क्वेश्चन है, अब मेरे को आंसर बता, तो वो अपने लैंग्वेज में आंसर बता सकता है, राइट?
Okay,
है
okay,
ना?
okay.
तो अब
It
उसके
can
पास वो
understand
इंटेलिजेंस
the
है.
prompt.
हाँ, राइट, राइट.
Okay, got it.
Earlier, the problem was it was not able to understand the English language properly. Okay, if you give large text, then it will able to understand the entire
Those double
content,
meaning
and
words it could not have understand.
could not understand, and it was failing.
Got
अभी ये after coming of this transformer architecture, now it is, it is able to retain its past learnings, and then even if you give 100 pages of text, it will be able to understand. It will not forget the first page, second page once it is on 99 page, right?
Got it.
So
Thank you.
I hope you can see my screen. Okay, so on rag session. Okay, so if you have your keys and all ready, you can follow along. Okay, so the first thing, so what all we need to do is we need to do some imports. Okay, then I'm just putting the strategy, do some imports, and then import my keys. What I will be using? Okay, I will be using first of all LangChain. I will be using Grok. In the Grok, with the help of Grok, I will be using some Llama 3.3 model. So this is my LLM. Okay, this LLM I will be using large language model. For embedding models, what I will be using OpenAI embedding models. Okay, and vector database, I can use Chroma, Vector DB. Okay, and then what I will do? So let's start. Okay, so first of all, install libraries. So let's start from installing. So let me. Okay, so what I'm doing is pip install -uq quiet mode upgrade mode LangChain community. For third-party integrations, LangChain Chroma, the library to support Chroma database with the help of LangChain Grok, so that we can call Grok APIs to invoke our large language model, and LangChain OpenAI. OpenAI we are just using for embedding models, not for large language models. Correct? So let's install. Meanwhile, I will show you the OpenAI documentation. Where is the documentation? OpenAI models. So in the left hand side, you can see embeddings. Okay. So you will read about embeddings if you want. And I am interested in embedding models. So let me go to the models then. Models. In the models, GPT-4o, 4o mini, context window, model, snapshot. Embedding models are in embedding only, I think. Embeddings. Okay. So these are the three models from OpenAI. Text embedding 3 large, which has 3072 dimensions. The small one, which has 1536, and this is text embedding ADA. ADA, small and large. Three embedding models available from OpenAI. Other than that, if I go to, let me go to LangChain. On the LangChain, if I go to documentation, so now I am talking about the vector stores. Okay. In documentation, if you go into the integrations and then embedding models, you can see, vector stores. Okay. So these are the vector stores which are available. So if you want to get some assistance in coding, they have changed a little bit. And now you can select your embedding models. If you're using OpenAI, then this piece of code will work. And you can switch to your, let's say I want to see how I can use Hugging Face embedding models. So if I click on Hugging Face, it will show me. From first of all, you need to install this LangChain Hugging Face library. And then you can use this piece of code, right? Embeddings is equal to Hugging Face. Embedding is equal to Hugging Face embeddings, and this is the model name. Sentence transformers all MPNet base v2. So if you want to use Hugging Face embedding, you have not added your credit card into OpenAI, then you can use this one also. Okay. Hugging Face embedding model you can use. Just copy paste these lines, install this library, and you are good to go. And as far as the vector stores are concerned, so these are the vector stores which are supported by LangChain. In memory, XDB, Chroma, Faz, Milvus, MongoDB, pgvector, Pinecone, Quadrant, these are a few famous. So let's say if I want to use Chroma database, this is what I need to do. Pip install LangChain Chroma, which we just did. And you have to import the Chroma, and then embedding function is equal to embedding. Simple. And their characteristics are also listed here. So there are a lot of vector databases. The entire list is here. Okay. Whenever you are stuck, you should come to the LangChain and just go to the documentation. You will get sample code as well. Very helpful. So that was on the vector store, and we will be using ChromaDB, and we will be using OpenAI embedding model. So this is the code which we are going to use. Okay. Let me show you some other things. We were talking about loaders, right? Document loaders. So there are a lot of loaders which are available. If you want to get the data from the web pages, you can use this web loader, unstructured, retrieval, sitemap, doclink. If you have PDF as the source, you can use PyPDF. You will be using this one, PyPDF, unstructured, and all those. Okay. So based on your input file or your data source, you can come to this particular page and you can see if you want to load AWS S3 directory, AWS S3 file, everything is given here. Okay. We will be using PyPDF for loading our data. I hope this is also clear. What else? And then we will go to Grok also. Grok documentation. Grok we will use as a platform which will host our open source models. Which model we are going to use? We can go into the models page. Here we have the models, and in the models we will be using These are all the open source models: Gemma, Llama 3.3, 70B, Versatile. So we will use this one. This is the latest 3.3 with 70 billion parameters. Okay. So this is how you read your the name of the models. Llama. Okay. This is from Facebook, Meta. Meta Llama is the model name. This is the version 3.3. 70B is the number of parameters. Just think, you have a neural network with 70 billion parameters. Okay. And this is the Versatile. You have the older one, 3.18 billion. So these are the smaller models, 8 billion. This is Llama Guard. This is 70 billion. If you want to install sometime any model on your laptop, you should be looking the models which are smaller in size, maybe like 8 billion or less than that, 3 billion. Okay. So that kind of models you can try to download on your system. You can use Ollama. There is something called as the Ollama. Maybe I will explain you in some other lecture. Okay, these are the whisper models. They are used to convert your audio into text. Okay, so yeah, so for our session we will be using 3.3. Cool. All right, our libraries have got installed. Clear the output. Super. So now what we need to import OS.
सुरेंद्र उसको पेस्ट कर देना तो आप तैयार होगा उसको
ये वाली सारी
हाँ पेस्ट कर देना
ये पूरा फाइल ही एक संग शेयर कर देंगे ना लास्ट में
हाँ वो
मतलब
लास्ट में तो कर दूंगा
हाँ ठीक है फिर ठीक है नो प्रॉब्लम
किसी को साथ में करना हो तो आई कैन कहाँ गया
So, Surendra, as part of this example, are we going to download the model and are we going to use?
For this session, we are going to use Grok. We are not going to download the model. Okay.
Okay.
We will use Grok API to invoke the Llama 3.3 70 billion model. Okay. So import OS, and then as you know already, I will go to my keys, and I have my keys in my secret. This we have discussed earlier also. I have my Grok API, LangChain API, and then OpenAI API. Okay, these three APIs are useful.
Any roughly idea how much these models, if we download it in local machine, how much space is required?
So it depends the size of the model itself. It starts from 1 GB, 2 GB, and then 100 GB, or maybe even more than that. Okay. So if you want to download, you can download the models with a parameter of 3 billion. That will be around 2 GB, and 7 billion will be around 4 GB. Okay. Then there is something called the quantized model. You can use the quantized models also. They become small in size. Okay. I will cover, I think, in some other session in detail, so that.
As of now, we are not using locally. We are
No. That was just. So let me quickly do all these things. And now what I need to do, os.environ equal to okay. Okay, my import is done. Now what next? What next we should do is import the libraries. We installed them. Now we will import them. So from LangChain community, the document loaders, which is PyPDF loader, which is being used to load our data and extract the text. LangChain _chroma for the Chroma database. LangChain _ OpenAI for OpenAI embeddings, text splitters, the library which will split the documents into different text. Output parsers to parse my output, runnables, runnable pass through. Okay, super. Now it will be very smooth, right? So what I need to do is I have created one PDF file. This is the PDF file, Saran AI Labs. Okay, so I will browse this one and I will bring it to my Google Colab. Okay, so if you do something like ls, what you will see your files here. In this directory, you have sample data and you have your Saran Labs, which I just uploaded. So should I give you, although you can use any PDF file of your choice. Okay, so this is in my current directory. So what I will do next is I will use my loader to load this file. Okay, I have given the path. Since this is in my current directory, I simply given it in the double quotes, and this is PyPDF loader. Okay, so this is coming from my library document loader from the LangChain, PyPDF loader, and I will give the file as an input. It will create the loader. Once I do loader.load, it will create the documents. Module not found, LangChain community. No module PyPDF. Okay, so I have not installed PyPDF. Okay, this is done. Let me rerun my loader. It will load. It has loaded. So let me open this file so that you can see what is there inside my input PDF file. Okay, guys, please stop me if you're lagging behind or if you are not able to understand anything. Okay, so this is my sample PDF file. This is some fictitious company, a Saran AI Labs, and I have created 4-page long PDF. This can be 10, 40, 100. That's fine. But since we need to create embeddings and all, we can use a smaller one. So this tells about this particular company, right? Saran AI Labs, what they are doing, what is their vision and mission, and what are the employee benefits. So this is like some onboarding PDF file. Whenever there is an employee who joins this company, we are going to create one chatbot which will help him to get his questions answered. Okay, whatever policies which are there, your reimbursement policy, your data security, if that onboarded employee has any questions, instead of going to the HR, he can simply ask his questions to this chatbot, and the replies will be based on this input document. So in real life, there will be 50 or 100 such PDFs which has the company's policies, their sick leave, promotion policies, and their transfer policies and all those things. So what we should be doing is we need to take all those things, we need to vectorize them, and we need to put it into the vector database. Okay, so right now this is the small PDF file. Okay, and I have browsed this file and I have loaded this file. So you can see it has 4 pages. Okay, so it has just 4 pages. Now once I
We are
load
not
my,
able to
We don't
see
see the PDF. We just
oh,
see this collab.
so sorry, yeah. I have shared that PDF also in the chat also.
Mhm.
Okay, I can show that. You can see now.
Yes.
Okay, so this is a small PDF file on some company, Saran AI Labs. It has the information about the different vision, mission, employee benefits, and things like that. Okay, so this will vectorize so that newly onboarded people can ask their questions. Okay, I think the motive is clear. So now what we have done is I have created the documents. Now let's see what is the length of my documents. This is a list of documents. I can see there are 4 documents which are being created. So this documents is nothing but this is an LangChain document object. Okay, and there are total number of 4 such documents, and we had just 4 pages in our PDF. That means 1 page for 1 document. So if I want to see my first page, what I can do is I can do print, and the indexing starts from 0. So if I do this print doc 0, what I will see is it has that content, right? Or maybe first, let me show you simply docs 0. If you do that, you will see this is a document object. Okay, we are accessing the first page or the first document, which is nothing but an instance of LangChain document object. And then it has something called as the metadata. What is the source of this particular document? Saran AI lab.pdf file. This is the name of the PDF files which I gave as an input. Okay, and this is coming from the page 0. The page content, what we have in the content. So this is one thing. This is one element, metadata. Okay, this is dictionary. Source is this one, page is 0, and then page content. Welcome to whatever content I had on my PDF that has come to my first element of this docs list. Saran AI, blah, blah, blah. Welcome to Saran AI, about Saran AI, all those things. Clear? Now, if I want to see it in a more clear, if I do print, what will happen? This next line and everything will be removed. Now I can see the page content. In fact, I can go inside my page content dot page underscore content. If I do that, I will see the page content. Welcome to Saran AI, page 1, about Saran AI. So what I have done is I have essentially extracted my text. So you remember this diagram, right? This is the PDF loader which I have used, and now I have this text. I hope you can see my deck.
Yes, yes.
Okay?
Yes.
So we have taken a PDF, we have used one PDF, LangChain PDF loader, and we created those docs. So these are docs, document loader, docs, doc 1, doc 2, doc 3. Okay.
So, Suren, just a general question. Like you printed docs of 0 and then print of docs of 0. So, what is the basic difference? I mean, at the back end, what is the difference?
So this is just print command, right? Which basically format your text for you. It just remove these next lines and format it nicely. That print library. Okay. Nothing.
Okay.
In your content, I mean, this is all these things are there in the content. Okay.
So,
In your doc
what is
1.
its type? It's just a text type, or
No, this is a document object. There is a class in this LangChain which is called document. Okay. This is a LangChain document object. Or maybe let me show you here
I think it
itself.
was list also, right? That's why we are specifying 0.
So this is a list of documents. No, this is a list. If I do type, you will see LangChain document. Okay, LangChain underscore code dot document dot base dot document. Okay, and there are 4 such documents, 4 such objects of the document type. So I am accessing the first one. Okay. If you do type docs, it will be list. Okay, list of what? List of such documents. 0, 1, 2, 3. I hope it is clear.
Yes.
Okay. This print command is just helping to display it in a better way. So this is my first. I can similarly see first, second, and third page also. Okay. Now my next is what I should do in my diagram. I need to create those chunks, right? So I need to have the document splitter. So for that, what I will do, so recursive text splitter, this is also coming from LangChain. Okay, so there are lot different type of these splitters. It basically tells how you are actually creating chunks of your source document. Okay, so that depends on your requirement. So you can, there are, around 5 to 10 different splitters. And right now I am using recursive character text splitter, and the chunk size I am giving is 500. I'm saying my chunk you are creating should be of 500 length, and there should be an overlap of 100 characters. Okay.
Surinder, where we can get this information, like 10 types of splitter, and we can
So yeah,
get the documentation and all.
Everything from LangChain documentation.
Okay, got it.
Okay.
And how we can decide we are going with the 500 size of chunk, or it would be a per requirement, or how we can decide?
That will be based on your input documents, right? On your requirements also, what kind of documents you have. If you have, let's say, if you are vectorizing your novel, which is divided into different chapters, chapter 1, chapter 2, chapter 3. So what you can do is you can keep one chapter in one chunk. Okay. If you want to do like that, you can create, there are different type of splitters. So that will help you to keep one chapter in one chunk, second chapter in the second chunk, and so on and so forth.
Okay, and it depends on only performance. If we are having a more chunk, then it would be reduce the performance, correct? Degrade the performance, like this one.
No. See, what we want, if we want our search to be very precise, if we keep very bigger chunks, then that particular chunk may be talking about several things, right? That let's say if we keep one chapter in one chunk, that chapter may have different type of conversations. At first, it may be talking where the writer used to live, and then how was his childhood and all those things. So if you want,
it means more chunk is a more precise answer, like this one.
No, more number of chunks is more precise. If you keep bigger chunks and if you are retrieving those chunks in your search, then you have lot of content, right? To process, to send to the large language model, that will add to your cost. So what we want is smaller chunks, okay, so that I can search the very specific information, and my token size is also limited. Okay. But then again, it depends on the requirement. You may have to do some hit and trial also. Okay. You have to engineer your correct chunk size. So I have taken 500, and then 100 is the overlapping. So this text splitter, once I get this splitter, I can split my documents. I can give these documents as a source. So those 4 documents, the list of 4 documents is sent as an input, and it will create the splits based on this criteria.
So then in this case, like, so we have the 4 pages of the document. So like that complete the 4 pages of the content will be split into the 500 chunks now?
No. These are characters. I will show you.
Okay.
So now my splits are ready. My splits are on the 500 characters. So my first 500 characters will be in the first split. Second 500 characters will be in the second split. But there is an overlap of 100. That means the second chunk will have the characters from 401 to 900. Getting? So let me show you. So if I calculate the length of split, how many splits are created? 12 are created. Okay. So out of those 4 pages, I'm creating 12 different chunks. I'm not creating one chunk per page. Rather, I am going into more deeper and creating smaller chunks. And now let's see what is my print splits. This is also a list page content. Super. And this is also a document doc type of. Okay. So my first chunk is having only this much information. Okay. So if I see my second chunk, this will have the next chunk, but you will see this particular line is common in both these. That's what I said. It should be overlapping 100 characters. Okay. Is it clear now?
And what are the significant of overlapping?
So overlapping is actually, so when I say my chunk size should be 500, so I don't want to truncate my sentences in the middle. Let's say that limit is completing till here, 500, first 500. Then what it will do is it will put these 500 in this one chunk, and starting from here, it will put the next 500 tokens into the next chunk, right? So by this way, my second chunk will not be able to understand what is this one. So in order to keep the context of what the document is talking about, right, for the continuity of the context which it is talking about, we keep actually certain characters common. Getting? So if I truncate in the middle, when I will create its embeddings, so this is not making much sense, right? Because it's an incomplete sentence. Okay. Similarly, it will not make any sense if I try to create chunk of this one. So when I do overlap, at least in either this one chunk or the second chunk, I will have correct representation of that sentence. Getting? And again, as I said, there are different ways to create chunks. There are ways where I can say my next chunk should start after the completion of sentence, or maybe after the full stop, or when the next paragraph starts, then it should start. So there are different ways for that. Okay. So though sometime I use markdown chunking. There are ways, actually, couple of ways. Okay. So now my chunks are ready. If I go back to my diagram, my chunks are ready. Now what? I need to put it into some vector representation. Okay, so for that, I need to use some vector database. So I will use my Chroma database as I defined. And in that, when I instantiate that Chroma DB, so there is a method called from documents. I can put documents equal to the splits. Okay, so these splits which we have created has been put as an input, and embedding model, which is OpenAI embedding. Okay, so this will return me a vector store, the vector database which we talked about. Now what we want, let's say there is something called the retriever. Okay, we can, in order to retrieve the documents from this vector database, we have something called as the retriever. So that retriever will go and it will pull the documents, will do the search, and then it will pull the documents from our vector database. Okay. So
where we converted the chunks to these numbers?
Here only.
Here only?
We have given the embedding model which is to be used, and I have also given the splits. Now what this will do is, this particular function will do, this will take all these splits one by one, and it will use this embedding model to create the vector representation, and it will store in the Chroma database. All the things are being done in this single line.
Okay.
Okay. Now from this vector database, if I need to retrieve something, I need to define one function which is called as retriever. Once I do that, I will have one object which will help me to retrieve documents from this database. Okay, if I'm using some other, I will have some API called FAISS faz dot from documents, and then the documents, all these splits and your embedding model. If I'm using some other embedding model, Hugging Face, then as I said, go to your the documentation page, see how we can use that, and then put that code here. Okay, embedding models.
So this OpenAI embedding we are using, then we should have that OpenAI key also, and then
Yes,
credit
yes,
card
yes,
information should be configured.
yes, yes. If you
Else you will not be able to use it.
if you want, you can use this Hugging Face, which I showed you earlier, right? This one.
Okay.
Just install this library, use this piece of line, whatever embedding you are getting, you can use this one in the right here.
Cool.
Surendra, if we download this, model locally, still we need that APIs.
When we download models, actually we are downloading the large language models. I have not used down because this is a one-time job, right? Vectorizing your data. Okay, so if I'm doing locally, I will download the large language model locally for inference. For creating embeddings, I used Hugging Face only.
Okay.
Okay. So I have now got the retriever. And any questions, guys? Okay, so what this retrieval will do? Retriever will help me to query. Okay, so this one important thing is this retriever is your what type of object? It's a runnable. Right? We learned a lot about runnables. So that's why what we can do, which method we can use with this runnable function? Retriever dot
invoke.
Invoke, exactly. So I can do retriever dot invoke, and I can ask my question, what is Saran AI Labs? This is my question. And what I can do is I can receive my output in this object. So what this retriever is doing is actually taking my question. It is going inside this vector database. It will create embedding of this sentence, and whatever embeddings we got created for my splits, it will compare those and it will send the response. So if I print this response, what I will have multiple chunks. Okay. What if I do simply response? Okay. So you can see what it is doing is it has given me couple of chunks, right? So this is document, this is ID, this is first chunk is coming from page 0, which is page 1. Okay. And the source is Saran AI Labs. The page content is welcome to, right? So this particular chunk was a bit similar to what is Saran AI Labs because it is talking about Saran AI Labs. So this vector for this chunk is very close to this my question vector. So it has pulled this first chunk. Okay. What about the other? Next chunk is coming from the page 3 from this PDF. Since we have one PDF, it will be always same. The page content, page 10. And this should also be talking about my Saran ABI. Contact is Saran AI Labs. Okay. So this also has that particular word Saran AI Labs. So it has taken this also as the similar chunk. And then the third one also and fourth one also. This is also talking about Saran AI Labs. We prioritize blah, blah, blah. So these are the top four matching chunks which my retriever has brought. Now, so if I go back to my this one, okay, so these are the chunks which have been retrieved. Okay, right
Where
now.
did you mention that it should retrieve only 4 chunks?
So it is by default 4. If you want to change, I think this retriever will have some parameters. Okay, यहाँ पे you can give maximum or k equal to, I think k is that keyword, k equal to 5, 10, whatever you want. Okay, I need to check the API reference for that.
And Surinder, actually, somewhere I have read out is a k value is depend on how precise the search will give the result. That is k value depends.
Sorry, how precise? No, the
Yeah,
k.
actually, for some time, actually, one practical I had done when put the k equal to 2, I'm not getting the precise search there. When I put the k equal to 5, then I get the answer of my question.
So that is because when you do k equal to 2, it is only retrieving 2 chunks, right? The 2 most similar chunks, but that does not mean that your question is answered in those chunks. They are just similar. Maybe your answer lies in the third, fourth, and fifth chunk, which you have not retrieved when you do k equal to 2, right? When you do k equal to 5, then almost all the chunks which are there, which are similar to the question, will be brought, and the answer will be retrieved from all those 5 chunks by large language model, right? So there are problems actually with this one. So yeah.
So Surendra, I think we can do without retrieval also, right? Yes, no?
Retrieval without retrieval, how? Means?
Okay. I will just share my screen quickly. I have done.
So can I complete this one and then we'll see? I just want to complete.
Let's complete this flow.
Okay, sure.
Okay, and then we can see. Okay, so we have reached up till here, right? Now, but this will actually be done in the backend by our chain, right? So right now I have just done it explicitly for you, but once we create the chain and all, it will be done by itself. Now, what we need to do is we need to create our prompt. Okay, so let me put that code. Here what I'm doing is I'm using chat prompt template. Okay, this we have done a couple of times in the past. And what I will be doing is define a custom prompt. This is my template. You are an onboarding assistant for certain AI labs that answer questions based on context provided below, and this is the context. So whatever I will retrieve from my vector database will be put here in this variable, which is called context. And my question should also be passed to this template as a question. Okay, so these two things are I need to provide to this particular prompt. Okay, so this is how we build that system prompt or prompts for our applications. Okay, so context and question we will be providing, and then
Sorry, Surendra, what is the difference between system prompts and normal prompt? Is there any difference?
yes, we have 3 type of prompts. One is system prompt, one is user prompt, and one is AI prompt. System prompt is always remains same most of the time. That basically guides the behavior of your chatbot, the personality of the chatbot. Okay, we will talk more about that one once we. Right now we are doing in the Google Colab, right? We will do all this exercise in our Streamlit application. Okay, so there I will show you one big system prompt. Okay, so this is my prompt. Okay, and then I have created this prompt from template, and this template I will be passing in my chat prompt. Okay, we can use different things. There are different ways to create from messages, from templates, and right. So right now I'm using from template. And what next? Once and then there is a function which will basically this is a helper function which will format my documents. Okay, it will just join all those chunks which are there. Okay, then my language model, I will be using Grok, as I said. So let me import it, and then let me set the large language model. LLM is chat Grok, model name is 3.370 billion. We saw on the website. What next? The most important part, creating the RAG chain. So now what I will do is, this is my chain. LangChain chain. In the chain, I'm saying this is my prompt. The prompt will be given to the large language model, and the output from the LLM will be sent to the my string output parser. But as I said, my prompt is looking for two different values. One is what? One is your context, and other is your question. Okay. So as the first step in my chain, I will create this dictionary, and the content will be coming from where? From where I will get the context, the most relevant chunks from retriever, right? Which we have defined here. This is my retriever. And so I am passing my retriever, and the output from the retriever first will be sent to the format document, my custom function. So I have coerced my function with this chain. So this is a mini chain within my chain. Okay, so all this we have discussed in the LangChain, right? And then my question will be passed as a runnable pass through, right? When I invoke this chain, my question will be passed as is to the prompt. Is it clear or not? That's why we put a lot of efforts in studying LangChain, because this is very simple now, right? So when, okay, let me invoke this one first. So now I need to do is LangChain is runnable, so I can do invoke. And my question is like, what is Saran AI Labs? So what will happen? This question, this is a question, okay? This, when I invoke this chain, this question will be passed to my first runnable, okay? It will be passed to the retriever. Automatically, it will be passed to the retriever. Retriever will take this question, will do its search on the vector database. It will pull 4 document chunks. It will send those chunks to the format documents. It will append all those chunks with each other, and the entire content will be sent to my context. Okay, because context is there in my prompt. My prompt is looking for just 2 values. Okay, my next component is prompt, and it is looking for 2 values. So I'm creating a dictionary of these 2 values, context and question. Once I ask the question, it will go to retriever. It will pull the documents from vector database. It will format those documents, and the output will be sent as a context. And this is key, and this is value. Next key is question. So this is a runnable pass through. The same question will be passed as is. So once I pass this dictionary to my prompt, I will have the key value pairs. And then it's very simple. I run this chain, and it tells me Saran AI Lab is a pioneer organization dedicated to advancing the field of generative AI and its application. It is a company that focuses on building AI-driven application. Now you can see how beautifully the large language model has synthesized the final answer. So we just passed these chunks, and it was able to, construct the final response. Is it clear, guys?
So it is a summarization, correct, Suren? It is summarization.
Yeah. Yes. Summarization, synthesis, whatever you call it.
Surendra, so if we want to check the preciseness for the response, so like this was the generic question and the document is also very generic. So suppose we want to check the preciseness, then what should we do? Like,
we should be doing something in our prompt. I can write, you should always start answering with how can I help you? Something like that. So whatever instructions you do, that LLM will follow. Okay, in your
no,
template.
but what I want to ask, like, suppose my document is having some specific instructions which I want to retrieve, and through reg I have chunked it and properly loaded the data in vector database, and through LLM I'm trying to fetch those steps, and those steps are very precise. So if I want to check that my LLM is giving me precise information or not, then what is there any mechanism we have to validate that it is the answers are precise?
No, I mean, only thing you can do is you can guide. I mean, see, the first thing is whatever precise information is there in the vector database. First of all, we need to make sure that is reaching to the large language model. Those steps are reaching. So our mechanism of fetching the data should be good enough. Once we have the proper context, then we need to instruct the LLM. Whatever information is provided, you have to give the concise answers. Those answers should be in the 5 lines, 6 lines, or okay. We should always complete answering by saying happy to help you, something like that. Let's try this one. Okay, happy to help you. Okay.
Yes.
Okay, so this is how, let me show you how you can do all these things in your Streamlit. Okay. So now you have the code which is running, which I will share with you. What you have to do is you have to create this GUI, which will have this functionality of onboarding. Okay. Let me show you once. Here is my
One thing I need to confirm, Surendra, here you got this document in Google Colab itself. You imported it here, na? So how we can get a document from a local machine or from any cloud, cloud location?
So that's, I mean, I have shown you those loaders, right? From the LangChain loaders. If you want to take some documents which has some link, then you can use that web loader. If you have document in your S3, then you can use S3 loader. In that case, you need to provide username, password, whatever authentication is required for it. So those loaders will help you actually.
Okay, because I'm about to plan it importing from our local machine, from a local desktop. So
Then you can give the path of your local desktop, no? For example, in this application which I have created, I am just I have put the data in my data folder, which is on my local machine, and then I will give the path dot data and this one, right? Dot data Saran AI labs.
Okay, let me try.
Right now, where I VNV1. What happened? Is not recognize the name of the command prompt. What spelling? I have deleted this or what? Okay. Okay, my virtual environment is activated. I will just try to run if this is working.
We can see just Google Colabs.
Okay. Let me share. Okay, this VS Code is not shared. So what I was showing is I was showing this VS Code. Okay. So in this VS Code, what I have done is I have used the same piece of code, but I have structured in such a way that I can create UI. Okay, this is my virtual environment. So I created this app.py, which is my main file, which I have run. And in order to give the local path, you can create this data folder and then you can put your PDF file and then you can give the path. Okay, so if I let me do Control C, let me run it again. So Streamlit run app.py file. Meanwhile, I will just tell you the structure of this project. So this is my workspace project, Saran AI Labs. Within that, I have created this data folder, which is having all these files, these source files. You can just take one. And then there is something called as the employee.py file. So what this will do is this employee.py file, when I run this particular class or this method, it will generate one data of a user. Okay, let me show you. Okay, so when I run this application, what will happen in the left-hand side, I can see this corporation and then some data, right? So you can see Joseph. This is a Joseph Bone. So this data is being generated by my code. Okay, this is some random data. Okay, this location is Saran AI, this hiring data is so. Okay, so this data along with my question, I am giving it to the large language model. Okay, so I'm creating some profile of the user hypothetically by using this function. Okay, so this is for that. If I go to app.py file, this is my main file where I have done all the imports. This is my main function. I'm loading my environment. I have this .env file which has all the keys, and then I'm setting my page configurations, the page title, all those things. And then as we studied, I have created this get user data. So this is to get the user data from this file, employee.py file. And I'm also have created these decorators now should be, you should be able to understand. I'm caching my user data and I'm also caching my vector store. So this is another function which is initialize vector store. I'm using PyPDF loader and document same code, recursive characters, 500 overlap, passing it to my text splitter, my embedding function. Here I'm using Hugging Face model. Okay, once I have that, I'm creating my vector store, passing splits. This time I'm using FAISS database instead of Chroma. So I'm passing my splits, my embeddings. This returns me a vector store, some exception handling, and then vector store is being created with the help by calling this function. I'm just passing this as a path. And if vector store is none, then I'm instantiating my large language model, Grok. This is my system prompt. So for that, I created a different file. So this file will do what? This class, I am telling it the behavior of my chatbot. So you can see once I have run this application, it is automatically giving me some welcome message. Welcome to Saran AI. Your integration into operation has been noted. As you begin your journey with us, you are expected to familiarize yourself, blah, 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 blah. Okay, so I can ask any questions like how to raise IT ticket. So what it will do is it will use the information which is there in my PDF. Okay, probably I have something IT setup or company policies. Okay, IT support, this email ID is there. So it will use all those information and it is addressing me because I have created this dummy data. So this I am passing the large language model, my profile, Joseph Bonet. Joseph Bonet as an IT specialist. Now it knows what is my role. So whatever my answer which is being there, it is, tailored as per my profile, as per my role and profile and all those things which I am giving in my prompt. So IT system for raising the help desk to initiate a ticket according to the following place, blah, 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 upon submission. Okay. So this is all. Again, let me go back to my code. So this is my system prompt. I'm saying you are an AI assistant, onboarding assistant. and you have access to this data, two type of data. One is employee information, which I will pass as an employee information variable, retrieved policy, which I will retrieve from the vector database. And then these are the guidelines. So these are the most important. What tone you have to keep, how to handle employees' queries. Okay, so these actually control the behavior of your chatbot, which is the most important. Since this will be deployed to some company or organization, its tone is very important. Security and policies, your escalation. So someone was asking about what is system prompt, right? So this is what the system prompt is, which basically decides the personality of your assistant, how it will behave with you, how it will create the responses. Welcome message, I have also defined what welcome message you should give. This is exactly the message which I saw on my this bot, right? So all these can be customized. So there is a separate file for that prompts, and in my app.py file I am using system prompt as a system prompt, welcome message, customer data by calling that function. And then this we have already seen how to store messages in a session state. Okay, and then I have created a separate class for assistant. Okay, see, I can do pretty much everything in my single page. In app.py file, I can do almost everything, but in order to make it, more organized way, more modular way, so that tomorrow, if you are going to any company, you can use this structure, you can replace maybe Streamlit code with any other code. So I'm trying to segregating all the things in the different files. Okay, so I have created this assistant.py file, which is my assistant. It has some init method. These are the different variables I'm initializing. I'm creating get response, get conversation chain. All these things are there. Then finally, I have one GUI file, which will decide how my UI will look like. Okay, what is the logo and how I am creating these user inputs, how to render the inputs, render messages, everything. That's pretty much, this is requirement.txt file, the list of all the libraries which I'm using. So this is your homework. Now I will share that code, not this one, the Google Colab code, and you try creating some UI. May not be like this, whatever you can do, maybe in a single page also, you can write all your code in app.py files. Try to create those memory things, make it conversational so that it can remember the conversation. And yeah, was that useful, guys? Is it clear?
Yes, yes, sir.
Yes, sir.
Any
So,
questions? Yeah.
yeah, regarding this vector store, maybe like
Mm-hmm.
so like earlier we used Chroma, and this time we are using the FAISS, right? So like maybe like where is the vector store? Is it locally now, or
It's locally. So what I can do is
can
there
we
are
access to that vector store if you
yes, I
explicitly?
mean it will be a file only. Okay.
Okay.
So it's up to you how you create. You can create in memory also, so that once you stop your execution, it will be removed. If you want to make it persistent, you have to explicitly save your vector database in a particular file or location. Okay, let me share some information. Let's say I'm using FAII. कहाँ गया? This is embedding model, sorry. Vector stores. Sorry. FAISS. Let me go into further details. All these are vector databases which are supported by LangChain. This is the one I'm using in my VS Code. So if you go there now, everything is being given how to set this up, what library you need to install, how do you initialize your embedding models. If you're using Hugging Face, select Hugging Face, it will give you that specific code. This is exactly what I'm using in my, and then import FAISS. This is how you need to initialize your vector stores. Once it is created, how to manage. This is what.
Okay.
Okay, how you can query vector database, query directly. There was one function with the help of which you can save your database to your local machine, saving and loading. Okay, so if you want to save, you should use load local index, allow dangerous deceleration true. Okay, so whatever path you give, it will load your database into that, save your database into that particular location. And next time when you run your application, you just need to load the database from that location. You need not to create embeddings each time. Okay, if you want to merge two databases, this is how you can do. In future, if you have more documents which are coming to your vector database, how you can add those documents, everything is there.
So, Suren, there is a one query. For example, a production application, and we have a very huge vector database. Then how we can manage that vector database? Because for example, we are putting the very small example and put the vector store in our local system. But in case of the application is productionized, and we have a huge vector database, then how we can in operation things, how we can take care of that?
So I mean, you have to use Pinecone or any similar database, right? MongoDB is also a vector database. You have to take license. You have to do anything which we do for enterprise level, right? Maybe in the Azure or whatever platform you have to take the licenses of the Pinecone, and then you have to use your embedding models to load your data. Okay.
So in industry, this ChromaDB and Pinecone and FIS, people are using for
Yes,
production
they are doing.
application.
They are using Pinecone. I mean,
Pinecone.
this is what I have seen. Chroma, FAS, they are being used for POCs and very simpler things. Okay.
So Pinecone we can store in the Redis and like
Yes,
in
yes.
cloud. Okay. Okay.
I think you can use these also. Chroma and all these can be used for the production also. But Pinecone is something I have seen the most. Okay. Okay. So anything else? Any other question?
Yes, then one thing I wanted to share one code.
Yeah. Let me stop my sharing. Yeah.
So it's a basic only. Can you see?
Yes, I can see your screen. Fetch
So
from documents. Okay.
yeah, so there are two things. One is you didn't specify this model, right? You just used OpenAI model here only when creating. So I mean, is there any difference when we specify which model
Well,
should be used?
I mean, if you specify, then it will use that specific. Otherwise, it will use some default model which is there defined by default, right?
Okay.
Just in case
Okay.
of Grok, if you don't specify, it will use Mixtral. If you explicitly tell I need Llama 3.3, then it will use Llama 3.3.
Okay, and for the other part, like you use retrieval. So I was just, I mean, I just used this query and used similarity search, and it was giving me the answers. I mean, I didn't use retrieval to get for this particular case, and
So
it was giving.
retriever is the LangChain function actually. Okay, so that's why I used it. There are, I mean, the implementation can vary, right? What library you are using. So that
Yeah,
depends
so
on that.
yeah, that's what my question is. Like, there could be another implementation, and that could also give
Yes.
this
Yeah,
result. So
exactly.
so similarly, like the one which you created chain. So I something I mean it was similar but little bit different way. Like I use LLM and prawn, and then I use retrieval, and then I mean I didn't use like STD output parser or like the one you created. So I mean I just wanted to understand the standard practice. Like, is there any standard way, like you create the chain and then
Yeah, I
pass?
mean, see, if you're using the LangChain chain, then the things become very simpler, right? Because once you create the chain, the only thing you need to pass it to your chain is your question, and all the components are connected to each other by the chain, right? So you need not to
Yes.
worry about anything else. You just pass your question, and that question will be passed to your chain's first component. For example, we did, right? Contacts and
Yes.
questions were passed. So that is the most standard way to do it.
Okay. Okay, I think yeah, that's all
Yeah.
my doubts.
I mean, on internet, you will see different type of
Yeah,
implementations. But yes, whatever I have shown is coming from industry practice only. Okay.
Okay.
Even in my company also, I am using the same way.
Okay, sure.
Okay. Anything else?
Yeah,
Yeah.
Actually, sorry for I'm actually joining a bit late due to have some personal emergency. After 12 I'll join. So I missed the first things like what is the lecture is in first introduction, everything. Maybe I can show your video. That's makes sense to me. But it's I am feeling good to your slowing flow. It's not hurry as you are going very slow and questions every answer every question. It's facing me very well. But few things I need to take a suggestion about you. Like
So
actually
I
I
think,
have
yeah, I mean, we can talk separately. So this is my batch 1 actually, who are the regular students. So I think you have joined this first time, right? So
yes.
can you share your phone number? I will connect with you after this call because I don't want my batch 1 to, wait or to wait for this conversation, right? So they can
Yes.
give me your phone number, please, Manas. What is your phone number?
Sure. 99337
Mm-hmm.
066524
066 524.
Yes.
Okay. All right. So maybe if you have my number, you can ping me.
Yeah, I will ping you.
So okay. All right. So we'll connect later, Manas.
Yeah. Thank you. Then I can drop off.
Yes. I think everyone is going to drop now. So and any other question, batch?
Surendra, maybe can you take one session, maybe how we can deploy these models locally so that we can make use of it locally?
Deploy locally. Yes, I will do. I will do that.
Okay. Thank you.
All right. So if no one is having any other questions, maybe we can wrap up for today.
Yeah, thank you, Surendra. Thank you. We
Thank
would
you.
have multiple
Recording
things.
will be immediately available, no? So
Sorry,
can,
you want to talk
recording
something?
you are going to upload.
Yeah. So I will upload it. Yeah. Let me stop the recording also.
Okay. Thanks, Surinder.
Thank you.
Have a
Thanks,
great day.
everyone. Bye-bye.
Thank you, Suren. Bye.
Thank you, everyone.
Bye.